Hello everyone! In our last video, we wrote and ran our very first Java program together. But here is something I want to ask you. When you clicked that run button, did you ever wonder what actually happened behind the scenes? How did Eclipse take the code you wrote and turn it into something your computer could understand and execute? Today we are going to answer exactly that question. Understanding how Java works under the hood will make you a significantly better programmer. Because instead of just writing code and hoping it works, you will actually understand the journey your code takes from the moment you write it to the moment it runs. So, let's start with the big picture. When you write a Java program, your code goes through a very specific journey before it actually runs. Here is the flow. You as a programmer write the Java code. I'm sorry for my drawing, it's not too good. That code is saved in a file with the extension .java. For example, our previous file, which was first.p.java. So the file will be saved as a file .java. But here is something really important. Your computer cannot understand this Java code directly. Computers only understand very low-level instructions, and Java is a high-level human-readable language. So something needs to translate your Java code into a language the computer can work with. That something is the Java compiler. The Java compiler, also known as JavaC, is the tool that takes your .java file and converts it into something called bytecode. Let me write it on the screen. Java compiler, or JavaC, turn it into bytecode. Bytecode is a special intermediate language. It is not quite human-readable like Java, but it is something that is not raw machine code that your processor runs directly. It sits in the middle. The bytecode is saved in a file with the extension .class. So our first file was saved as .java. Then with the help of Java compiler, our file will be saved as .class. Extension with .class. So our previous class, which was firstb.java, became firstb.class. After compilation, now you might be wondering, why not compile Java directly into machine code like some other languages do? This is actually one of Java's most brilliant design decisions, and it leads us to one of Java's most famous features. Here is the thing about machine code. It is different for every operating system and every processor. Code compiled for Windows won't run on Mac. Code compiled on Mac won't run on Linux. This was a huge problem in early days of computing. Java solved this problem. Instead of compiling directly to machine code, Java compiles to bytecode, which is the same regardless of what operating system you are on. Then a special program called the JVM takes that bytecode and handles the translation to machine code on each specific platform. This means you write your Java code once, compile it once, and the resulting bytecode can run on your device, Windows, Mac, Linux, mobile phones, whatever, as long as a JVM is installed. So after Java C, we have the JVM. This is Java's famous promise: write once, run anywhere, also known as WORA. Write once, run anywhere. And this single feature is one of the biggest reasons Java became one of the most widely used languages in the world. So what exactly is the JVM? JVM stands for Java Virtual Machine. Java Virtual Machine. Think of it as a virtual computer that lives inside your real computer. Its one job is to take the bytecode that the compiler produces and execute it, translating it into machine code that your specific operating system and processor can understand. So after the JVM, we have the operating system. And after the operating system, you can successfully run the code on your computer or your hardware. So here is something interesting. While Java code and bytecode are platform independent, the JVM itself is actually platform dependent. This means there is a different version of the JVM for Windows, for Mac, and for Linux. Each one is built specifically for that operating system. But that is completely fine because the JVM is installed once on your machine, and after that, any Java bytecode can run on it without any changes. Now let's talk about something you have already seen in your code, the main method. When you run a Java code, the JVM needs to know exactly where to start executing your code. A program can have many files and many classes, so the JVM needs a clear starting point. The starting point is always the main method. The JVM looks for a method with this exact signature. Let me write it. Public. I'm sorry. I don't know what happened. Okay. There is a problem with my PC. Imagine it's public. Public static void main parenthesis open, I'm sorry, string RGS and close parenthesis. Let's quickly understand each word in the signature. Public. This means the method is accessible to everyone, including the JVM itself. Static. This means the method belongs to the class itself, not to any specific object. This is important because when the JVM starts, no objects have been created yet. So the main method must be static, so the JVM can call it directly. Void. This means the main method does not return any value. It just executes any and finish. Main. This is the specific name the JVM looks for. It must be spelled exactly like this, lowercase m, lowercase a, I, and n. And finally, string RGS. This allows the program to accept input from the command line when it is launched. Even if you never use it, it must be there as part of the signature. This specific combination of words is what exactly the JVM looks for every single time it runs a Java program. Change it in one word and the JVM will not recognize it as the entry point. So, don't worry about any of these words right now. We will talk about these all in details later, in later lessons. So, now let me briefly mention another fundamental concept about Java. Java is an object-oriented programming language. What that mean exactly? In object-oriented programming, everything is organized around objects. An object is simply a representation of something. It could be a person, like we have here. It can be a car. It can be a bank account or anything else. And in Java, every object is created from a class. A class is like a blueprint. It defines what properties and behaviors an object has. We are not going to go deep into object-oriented programming just yet. That is a topic we will explore in detail later in the series. But it is important to understand from the very beginning that this is the foundation Java is built on. Finally, let's clear up something that confuses almost every Java programmer: the difference between JVM, JRE, and JDK. Think of them like three nested layers. JVM, Java Virtual Machine, is the innermost layer, as we can see here. It is the engine that actually executes your bytecode. Without the JVM Java program simply cannot run. JRE, which stands for Java Runtime Environment, the middle layer, includes the JVM plus libraries and files that Java program needs to run. Let me show you on screen. If this is JVM, the second layer is JRE, this layer. So if you just want to run Java applications, not develop them, the JRE is all you need. And finally, the JDK, Java Development Kit, the outermost layer, and this is what we installed in Java in our second video. Let me just show on the screen. So this can be JDK, Java Development Kit, the outermost layer, and this is what we installed. The JDK includes everything in the JRE, plus the Java compiler and other development tools. So to summarize, we have JDK contains JRE, and finally JRE contains JVM, and JVM executes our bytecodes. So now let's look at the real piece of Java code. Let's open Eclipse and look at the code we wrote in our last video. So first, we wrote the code. This file is saved as first.p.java inside basics package. This is your human readable Java code, clear, logical, and easy to understand. So let's see if it's really saved as a .java file or not. I have already found the workspace my Java files are saving, so you can also find this workspace on your computer. For me, this file is saved in my drive D, in a folder named Java 2026, and the workspace named Java Workspace. So I click on src, click on com, click on basic, the package that we have created, and here is it, first.p.java. This is the file that we have written. In step 2, the compiler converts it to bytecode. The moment you click Run Eclipse, automatically calls the Java compiler, JavaC, and then the Java compiler reads first.p.java and converts it into bytecode, saved as first.p.class. This Bytecode is not longer human readable. It is an intermediate language designed specifically for JVM. So let's find this file as well. I go back. I click on the next folder bin. Click on com. Click on basic. And here it is firstb.class. So next the JVM or Java virtual machine receives the bytecode. The JVM picks up the firstb.class file and prepares to execute it. Remember, the JVM does not touch the .java file at all. It only works with .class bytecode files. The JVM looks for the main method then. Before executing anything, the JVM scans the class for the main method with its exact signature: public, static, void, main, string. So, it finds it inside our first B class. This is where execution will begin. The JVM executes the code inside main. The JVM enters the main method and starts executing line by line. It finds system.out.println and this message. It executes this instruction which tells the system to print the text hello world to the console output. Let me run the program. And then the output appears on your screen. The console panel at the bottom of Eclipse displays hello world, and that is the complete journey from the code you wrote all the way to the output on your screen. Notice also the package declaration at the very top. Package com.basics. This tells Java that this class belongs to the com.basics package we created. It helps organize our code and avoid naming conflicts as our projects grow larger. And notice the public keyword before the class name. So this means the class is accessible from anywhere in the project, which is required for the JVM to find and execute it. Now let's put everything together into one clear picture. You write Java code in a .java file. The Java compiler, part of the JDK, converts your code into bytecode, saved in a .class file. The JVM, part of the JRE, which is part of the JDK, takes that bytecode and executes it on your specific operating system because bytecode is platform independent. The same .class file can be executed by the JVM on any operating system like Windows, Mac, or Linux. And because execution always starts from the main method, the JVM knows exactly where to begin running your program. This entire system, the compiler, the bytecode, the JVM, the JRE, and the JDK, is what makes Java one of the most powerful, portable, and reliable programming languages. So, if you enjoyed this video, make sure to like and subscribe to Tech Power so you never miss a lesson. See you in the next one.